Hey everyone, how's it going? I'm Shahab and welcome back to our series on From Maps to AI Agents. So far we have learned some very interesting things, although basic, not really advanced, but we're gonna get there very quickly. But knowing about these basics, the building blocks of how to build agentic workflows is really, really important. So in this video, we're going to continue our journey on how to make our AI agent more capable. And one of the things that we are going to mainly focus on in this video is how to make our AI agent to be able to run different tools sequentially. So what does it mean? In many real-world applications, there are cases where the user's request or question may require the AI model to run several tools one after another. And this is called sequential tool calling. Let's see how this works in our app if we add that capability to the app so it would be able to run different tools one after another to provide the final results to the user. As an example, I just sent a request to the AI model, and what I wanted to do is to measure the distance from two different locations that I specify for it. In this case, what it should do is that it should first get the coordinates of the first location and the second location, and then it has to calculate the distance between them. So we already have all these tools. We have the tool that calculates the distance. We have implemented that already in the previous videos. And we have a tool that we'll add in this video that calculates or gets the coordinates of the address that we want it to be geocoded, and then it returns the longitude and latitude or the coordinates of the address. So let's see how this works and how this sequential tool calling can really help us in this example. So the question is that what's the distance between just the Walmart store in Bayshore in Ottawa and the Carling Shopping Center again in Ottawa? So let's ask the AI model. One thing that you now see is we have something called tool call, a new component that shows what is the tool that currently the AI model is calling. And you can see three tools or three tool calls. One is geocoding address or geocode address. The other one, again, geocode address. And the third one is calculate address. So why do we have two geocode address tool or tool calls? The reason is that we need the coordinates of the first address and also the coordinates of the second address. So that's why the same tool was called twice. And finally, when getting the coordinates, the AI tool knew that it now need to calculate the distance, and now it called the calculate distance tool. And then it finally returned the final distance between these two locations. So this is what we really need to have in a real-world application or an agentic application where the model would be able to run different tools sequentially. So we'll later see an example where you would be able to make your model run different tools in parallel. So that's a more advanced part that we'll do in a future video. But let's see how we can add this capability to our app. What are the different components and considerations, and what we should change in our app. So one of the main components that we have to add in this video is the geocoding tools. We already have a geocoding capability in our app. For example, when you want to search for an address, it's actually using the geocoding capability that we already have. And for that, we use Nominatum, which is a free geocoding provider. So we're going to also use that. We're going to extend this capability, the geocoding that we already have, and make it available to the LLM so it can use them as tools when the user request is related. So the first step to have the geocoding tools available to the LLM is to actually create the functions. And I don't want to reuse what we already have for the search address. Later in the next video, we'll integrate them into one function because we want to be dry, don't repeat yourself, which is a great practice to make sure that your code is organized and maintainable. But for now, for simplicity, I have created a different nominatum service for geocoding, and I've put that under the lib folder under geocoding feature. Okay, and you can see it in here. So in this file, we have several things. I just skip the simple parts like interfaces and things like that. And you have seen these before when we wanted to add the search address. And now we have 3 new functions in here. One is geocode address. The geocode address, actually what it does is that it converts the address, the string of your address, to coordinates, to lat and long in this case. Okay, so that's what it does. And we also have another function which is reverse geocoding. So the way that reverse geocoding works is actually you may have some coordinates, lat and long, and then you want to get the address, the string of the address. So that's what the reverse geocode coordinates function does. Okay, so you can see it in here. We also have another function that again does the reverse geocoding, but it returns a structured address. So rather than just giving you a string, it gives you an object where the different parts of the address can be accessed. So this is something that you can also do if you want to have more structured outputs. Now let's go to the geocoding tools. The geocoding tools is where we actually create or build the tools that the LLM would have access to. Okay, so we have done that already for, if you remember, for the basic geospatial analysis tools using turf. Now we want to add more geospatial tools, in this case geocoding, so the model can have access to them. So if you go to the lib folder under the AI assistant feature, we now have some new things. First of all, I added or created a new folder, LLM-tools, and then under it we have schemas. So schemas are the ZOD validation schemas that you learned in the previous videos. These are important, and for improving the maintainability of the app, I just added them or organized them like this. Okay, so it's now more organized and cleaner. And we also have basic geospatial tools. These are the geospatial tools, basic geospatial tools that we already had, calculate polygon, distance, and so on and so forth. And now we also have the geocoding tools that includes the functions or the tools that we are going to use for geocoding in our LLM. So what it does is that it's, again, nothing different from what we did or you learned in the previous videos, especially the last 2 ones. We use the tool function or method from the AI SDK. I went through this in very in-depth manner in the previous video, so if you didn't watch that video, check it out. And now we define the different parameters and description and also validation. And you can see the schema in here. For simplicity for this video, I put all the schema in the same file, but later, again, to improve the maintainability and scalability of the app, we need to move all these schemas to a separate file, just like how we did in this video for the GeoJSON schemas. Okay, so the first tool does the geocoding. So the geocoding, it gets the address and then it returns the lat and long. So for that, we're gonna use or reuse the geocoding that we have in here. Okay, so we call it or invoke it in here. And we also have the reverse geocoding and same, just again, we call or invoke the same function from here to here, okay, for reverse geocoding. And again, same for the structured geocoding. And finally, we return all these files as geocoding tools, okay? So This is exactly what we did for the basic geospatial tools using Turf. Now we're doing the same thing for the geocoding tools. So nothing really different. Same thing, same structure, same pattern. So we don't need this, and now we can go to the route. So the route, it's the chat route, if you remember. The chat route is where our LLM in the backend is hosted. So if I open it, you can see the different things that we had before. We don't need to change anything. The only thing that I changed in this video, also in the previous video, but I in this video want to use Google Gemini model, and the reason is that it's cheaper and it's really good and fast. So we don't need to change anything in here. Just make sure that the max steps is 10. Again, in the previous video, I went through what it means exactly, but in short, this is what you really need to make sure that your model, your LLM is able to run tools sequentially. So depending on how many tools it's going to run after one another, you need to set an appropriate value for the max steps parameter in here. So now we need to add the geocoding tools that we have in here and we export in here and include them into the tools for the LLM. So the LLM knows that these are the new tools that it also has access to. And for that, you can see that we already have the geospatial tools, and now we need to include the geocoding tools. Okay, so we spread them, and then they are going to be inside this object. Okay, so make sure that you spread them, otherwise you'll get an error. Let's now go to the constants. If you remember, we added the constants before, where we just put some of the parts that we don't change that much. And one of the things that we have in this file is the instructions or the system prompts for the LLM. So now I want to improve the system prompt to give more context about the new tools and the different things that the model has access to. Generally, for advanced models, for the models that are powerful enough, you don't need to mention these are the tools that the model has access to, but it's always best practice to do so. So giving more context to the LLM would improve the results that you'll get. So I just add some new things. I just say that you now have access to some tools. We didn't have these before, but now we need to add that because we're going to add more tools and it may confuse the LLM if we don't do so. So we say that these are the basic geospatial tools. Okay, so the names of the geospatial tools come here, and also it has access to geocoding tools. Again, the name of the geocoding tools comes in here, and then some more context about what it's supposed to do with these, and that's it. So nothing really complex so far. So in a future video, I will tell you what if this gets too big. Is it okay? May it confuse the LLM? Of course. So there is something that we're gonna explore later. In a prod application, you barely send the system prompts to the model like this because it's confusing. These models have not been trained in this way, so they can understand complex instructions like the simple string like this. Okay, so later we're gonna use an XML structure that was actually suggested and recommended by the Anthropic team, and we're going to explore that, and you will see why we should use an XML based structure for these system prompts. Now we need to go to the chat message component. So in this component now we have some new things. The first thing is the tool invocation parts. So where is it coming from? It comes from the message parts. Okay, so we talked about this in the previous video and the video before that, in the AI SDK, messages have parts, and so far you know that what each part contains and things like that. And we now want to know when a tool is called, what tool is called, what is the name, and then we want to get it. And for that, we need to extract the messages that have parts, and the part has a type of tool invocation, which means that a tool was called. Okay, and then we get it, and then we store everything, or the messages parts in this variable. And then we come in here, and then we actually map through the tool parts or the tools, and then extract them. You see that each tool invocation has a tool call ID. Again, make sure that you set the key. So after that, we see that the tool that we want to be shown and called is shown in here, where we get the part, the current part, and the tool invocation. And what is the name of the tool that was invoked? It's actually stored in this property. Okay, so simple, nothing really complex. And then the rest of the things are the messages that are shown that we have seen before, and some callback or fallbacks that we need to add in case we don't have any messages, or the messages list is empty, and things like that. And it's all set, but let's go back to the main or parent component, which is AI-chat. So in AI-chat, you again make sure that you have the max steps set to an appropriate number. Something that I said that I will talk about that later is there is a small difference between the max steps that we have in the front end and the one that we have in the back end. The difference is that in the back end, if you don't set it in here, the backend actually runs different tools one after another, but it doesn't return the results to the front end immediately. Okay, so the tools run after one another, and then when the final tool was called, the result of the final results or final tool call is returned to the front end. When you have the max steps set also in here, what happens is that after running each tool, the results immediately for that tool comes back to the front end. Okay, so that's the main difference. So now you can, for example, show it on the display in the UI or do whatever you want on the client side. But this is not something that you need to necessarily set. It depends if you want to get the result of each tool call or of each tool when it's called in the front end immediately, rather than just waiting for all the tools to be run and then getting one result back as a result of that tool call chain. I personally set it always to something close to the backend max step, because I generally use them one after another. There is nothing else that we need to change for this video, for this new capability. In a future video, we're gonna extend that to make sure that it would be able to handle more advanced complex cases. I hope that you enjoyed this video. Make sure to subscribe. Have a great day. Take care. Bye-bye.